Okay, let's go. Number 10. The Antikythera mechanism. In the spring of 1901, a crew of sponge divers anchored near a small rocky Greek island. They found the remains of an ancient Roman shipwreck scattered across the sea floor. Among the rotting wood and broken marble statues, they recovered a strange lump of calcified bronze. For months, it sat unnoticed. It looked like nothing more than a green, corroded rock. But as the wood dried and the centuries of salt hardened, the rock cracked open. It revealed something that absolutely should not exist. It was a machine. We are taught a very simple, comfortable story about ancient technology. We assume the ancient Greeks were brilliant philosophers and architects. We assume their physical engineering was limited to basic levers, heavy pulleys, and endless manual labor. The story says they built beautiful things, but they did not build complex machines. This single lump of bronze breaks that story completely. It is not a primitive tool. It is a highly sophisticated, hand-cranked mechanical computer. Inside that corroded outer shell is a dense network of interlocking bronze gears. Specifically, it relies on differential gears. These are highly advanced mechanisms designed to calculate multiple variables moving at different speeds. The device was engineered to track the precise movements of the sun, the moon, and the known planets. It predicted eclipses decades in advance. It even calculated the irregular elliptical orbit of the moon with mathematical perfection. It did all of this roughly 2,000 years ago. According to the standard timeline of human progress, differential gears were not invented until the year 1557. This bronze artifact predates that supposed invention by more than a millennium. This is not a myth recorded in a dusty, untrustworthy text. It is a physical object. You can walk into the National Archaeological Museum in Athens today and look at it. The cast bronze is real. The tiny triangular teeth of the gears are real. It is a hard physical fact sitting quietly behind glass. Its survival proves that a highly advanced mechanical lineage once existed. And then, for reasons we still cannot fully explain, that knowledge entirely vanished from the Earth. But the mystery goes deeper than the object itself. Because we have the physical artifact, modern engineers assumed it would be relatively simple to reverse engineer. We mapped the surviving gears. We counted the microscopic teeth. We built exact physical replicas using modern brass, steel, and precise machinery. But a strange thing happens when we try to put those perfect modern replicas in motion. They jam. The modern reconstructions bind up. The gears grind against each other, and the mechanism fails to turn smoothly. Without inserting hidden modern adjustments that the ancients did not use, we cannot make our replicas work the way the original clearly did. This changes the scale of the entire mystery. Finding the Antikythera mechanism is like digging up a functional jet engine buried in the Middle Ages. It proves that ancient engineers understood complex mechanical physics on a level we never expected. But the fact that our perfect replicas fail to run proves something much more unsettling. We have their blueprint. We can see exactly what they built, but we have completely lost the physical, intuitive knowledge required to actually put it together. The timeline of human progress is missing a critical piece. If you want to help us hunt down the rest of these missing pieces, leave a like, subscribe to the channel, and tell me in the comments exactly where in the world you are watching from. Because if a machine like this could be forgotten, we have to ask what else was erased. The answer to what was erased begins with a gap. For over a century, the rock with the gears inside was a silent mystery. The surface was too corroded to tell the whole story. Then, in 2006, the journal Nature published a landmark paper. Researchers had finally looked inside the bronze lump using advanced X-ray tomography. They did not just find a few overlapping wheels. They found a microscopic, three-dimensional labyrinth. To understand what those X-rays revealed, imagine the inside of a high-end modern mechanical watch. Now imagine it cut from raw bronze. It was designed not to track simple hours, but to compute the erratic shifting movements of the moon and planets. It did this using differential gears. These are complex mechanical systems that can physically add and subtract different rotational speeds. The gears do math through the physical interlocking of metal teeth. Standard history books say differential gears were not invented until the 16th century, yet here they were, perfectly aligned in a machine built thousands of years earlier. The 2006 scans gave us something unprecedented. They gave us the exact internal blueprint. We could count the teeth on every single gear. We could measure the exact spacing of the axles. We knew exactly how it was supposed to work. Naturally, modern engineers immediately tried to rebuild it. But this is where the simple version of the story breaks. When modern experts attempt to reconstruct the device using only the tools of the ancient era, the replicas jam. The metal binds. The gears grind against each other, and the delicate celestial calculations fail completely. To make a working model today, Modern watchmakers have to cheat. They have to use computer-guided lasers. They rely on modern friction adjustments and synthetic lubricants. This failure changes the entire conversation around ancient technology. It proves a hard, unsettling truth. Having the exact blueprint is not the same as having the institutional knowledge to build it. We have a perfect map of the machine. But a map does not teach you how to walk the road. The gap between the original and the replicas is not about knowing what they built. It is about knowing how they physically shaped and balanced the metal. The original ancient engineers possessed a deep physical intuition for metallurgy. They understood how to manage friction, weight, and tension in a way that modern science cannot easily replicate without modern shortcuts. We are left with a strange realization. We possess the physical hardware of the ancient world, but we are completely missing the tacit operational software of antiquity. The entire ecosystem of knowledge required to build and maintain these machines was entirely erased from human memory. The artifact survived the shipwreck, but the lineage of minds that knew how to make it run did not. This leaves us looking at an uncomfortable pattern. A bronze celestial calculator is just one isolated object. It fits in a wooden box. If our greatest modern engineers cannot replicate a single small bronze machine, what happens when the mystery scales up to massive infrastructure? Number 9. The Pier of Portus Cosenus. Off the western coast of Italy, massive blocks of stone and mortar sit completely submerged in the Mediterranean Sea. They have been battered by saltwater, storms, and pounding waves for over 2,000 years. If you look at the ruins today, they do not look like advanced technology. They look like simple gray rocks blending into the coastline. But these submerged blocks are completely intact. To understand why this physical survival is bordering on the impossible, we have to look at how we build the world right now. Modern marine concrete is considered a triumph of industrial engineering. We use it to build our massive seawalls, our bridges, and our deep-water ports. But modern concrete has a fatal, unavoidable flaw. The moment saltwater penetrates the surface, it begins to chemically attack the material and break down the internal steel reinforcements. Within 50 to 100 years, the structure cracks, rusts, and inevitably fails. Modern engineers spend billions of dollars every year just trying to delay this decay. Saltwater is the ultimate enemy of modern infrastructure. But for the ancient Roman engineers, saltwater was not the enemy. It was a required ingredient. To figure out how this was possible, an international research team known as the Roman Maritime Concrete Study, or ROMACONS for short, took a specialized drilling rig out into the ocean. They began drilling physical core samples directly into these ancient submerged piers. They wanted to know exactly why a 2,000-year-old Roman breakwater was effortlessly outlasting our modern equivalents. When the researchers pulled the cylinders of ancient concrete from the depths and put them under modern microscopes, they did not find simple dried mud and rocks. They found evidence of a highly complex, ongoing chemical reaction. This is not a myth about ancient magic, and it is not a lucky accident. This is a verified chemical engineering reality. The Roman builders deliberately mixed highly specific ratios of volcanic ash, quicklime, and seawater. They packed this volatile mixture into wooden forms directly in the ocean. The concrete actually cured underwater. While the relentless ocean battered the fresh foundations, the heat of the chemical reaction forged rare, interlocking minerals. Instead of breaking the structure down, the saltwater forced the concrete to grow stronger over the centuries. The ocean itself became an active part of the building process. Modern science is only just beginning to decode this massive operational control system. Researchers are using powerful electron microscopes and X-ray diffraction to map the exact mineral structures hidden inside the core samples. They are trying to reverse engineer a chemical process that ancient engineers perfected and deployed over 2 millennia ago. We have the physical core samples on the laboratory table. We can see the exact chemical signatures locked in the rock. But seeing the final result is very different from understanding the physical execution. We like to believe that modern infrastructure is the absolute peak of human achievement. We assume that older always means weaker, and that ancient builders relied on crude, temporary solutions. But the Pier of Portus Cosenus shatters that assumption. Ancient infrastructure outlasts modern equivalents by thousands of years. The Romans mastered a level of chemical curing and material science that we completely lost when their empire collapsed. They did not just build heavy walls. They engineered artificial stone that actively heals itself in the harshest marine environments on Earth. It is a level of chemical coordination that modern material science is still struggling to replicate. We now know what happened inside the concrete, and we know they did it on purpose. But that leaves us with a much harder logistical problem. Mixing a handful of volcanic ash and seawater in a controlled modern laboratory is one thing. Building a massive, functioning seawall in the open ocean is entirely different. How did they coordinate this complex chemical reaction on a massive infrastructural scale? You might assume the answer to that massive logistical problem was simply lost to time. But it was not. We actually have the instruction manual. Sometime in the 1st century BCE, a Roman architect and engineer named Vitruvius sat down and wrote a comprehensive guide to building the empire. The text is called De Architectura. It is not an abstract philosophical treatise. It is a highly specific, practical engineering blueprint. Against all odds, this text survived the collapse of the Roman world. Inside this manual, Vitruvius explicitly details the formula for their indestructible marine concrete. He does not just casually mention that they mixed some ash with seawater. He provides the exact material ratios. He specifies the exact type of volcanic ash known as pozzolana, mined from the volcanic regions around the Bay of Naples. He documents the precise proportion of this ash to be mixed with lime and rubble. He even describes how the mixture reacts when it is lowered into the sea, noting that the water itself causes the material to instantly harden into a single, unified stone mass. The instructions are completely clear. The chemical ingredients are clearly named. The ratios are written directly on the page. This creates a deeply uncomfortable paradox for modern engineering. We cannot claim that the Roman formula was completely erased by the Dark Ages. We literally have the book. The instructions have been sitting in libraries for centuries. We have the exact same raw volcanic materials. We have the modern translations, which makes our failure to easily and perfectly replicate their underwater results even stranger. To understand why having the book is not enough, you have to look at how physical things are actually made. Think about the difference between reading a manual and actually doing the work. Having a theoretical blueprint is exactly like having a complex recipe written by a master chef. The recipe might tell you the exact weight of the flour, it might give you the precise volume of the water, but the text does not tell you what the dough is actually supposed to feel like when you knead it with your own hands. It does not tell you if the ambient humidity in the room requires a slight adjustment to the water. It assumes you already know how to check the temperature of an ancient wood-fired kiln by simply looking at the color of the flame. That unwritten physical intuition is called tacit knowledge, and it is entirely missing from the Vitruvius blueprint. When modern engineers try to follow the 1st century BCE manual today, they run directly into this invisible wall. They encounter translation ambiguities. The ancient Latin terms for certain preparation phases do not perfectly align with modern chemical definitions. More importantly, the text assumes the reader already possesses the basic, everyday physical knowledge of a Roman builder. It assumes a baseline of operational competence that simply vanished. We can mix the exact ratios of volcanic ash and lime in a modern, climate-controlled laboratory. But the Romans were mixing tons of this volatile material on wooden barges, coordinating a massive thermal reaction over open ocean waves. Without the tacit knowledge of how they physically handled, transported, and cured the mixture in those extreme conditions, the modern result often falls short of the ancient reality. We are forced to admit a hard limit to our own capabilities. The chemical formula survived the centuries. The written instructions were perfectly preserved, but the exact physical execution of that formula remains totally elusive. We have their words, but we lost the hands that knew how to use them. But Roman concrete is just a static material. It sits quietly in the water and hardens over time. If surviving blueprints are not enough to help us rebuild a static seawall, what happens when the structures become complex? What happens when the machines themselves begin to move? Number 8. Heron's pneumatica. When we think of ancient machines moving, we usually picture a wooden wheel or a heavy catapult. We imagine a human being pulling a lever or an animal pushing a grindstone. But in the 1st century CE, a Greek mathematician named Heron of Alexandria wrote a text that shatters that simple assumption. The manuscript is called the Pneumatica. Inside its pages, Heron did not design basic manual tools. He designed programmable, wind-powered machines. To understand what this text actually represents, we have to look at it through the lens of modern automation. Today, we think of robotics as a strictly modern achievement. We define a robot as a machine that can execute a specific time sequence of commands without human intervention. Heron's text describes exactly exactly that. He built mechanical software out of water pressure, compressed air, falling weights, and carefully coiled ropes. The Pneumatica documents complex, programmable automata in exhausting detail. Heron details massive temple doors that automatically swing open when a priest lights a fire on a nearby altar. He describes mechanical birds that use water displacement to whistle and sing. He even outlines a completely automated puppet theater. This machine could roll itself onto a stage, perform a mechanical play with moving figures, drop flower petals, and then roll itself away. The device cycled through different actions based on a complex arrangement of hidden strings. Those strings acted as a physical form of binary code. The text is not a philosophical fantasy. It is a dry, highly specific engineering manual. It is very easy for modern historians to look at these devices and dismiss them as clever toys. They are often written off as simple royal amusements or theatrical temple tricks, but that safe, dismissive view completely ignores the engineering reality. Look closely at what it actually takes to keep a pneumatic automaton running in the real world. A complex machine filled with hidden valves, siphons, and moving gears cannot just be built once and left alone. These machines represent a deep institutional knowledge of automation. To operate a wind-powered or hydraulic engine, you need airtight metallic seals. You need perfectly balanced counterweights. You need pressurized systems that do not leak, jam, or degrade over time. Most importantly, you need a dedicated class of technicians who understand exactly how to fix the machine when it inevitably breaks. A completely automated, self-driving theater piece does not survive a decade without a highly specialized mechanic. But this is where the historical record hits a hard, unsettling wall. The institutional knowledge required to maintain these machines existed. It was fully documented. And then, it was entirely abandoned. The physical infrastructure of specialized maintenance simply evaporated from the ancient Mediterranean. The technicians died out. The invisible network of tacit knowledge that kept the gears turning was completely erased from history. The survival of Heron's text is a quiet warning. It proves that a civilization can achieve the foundational concepts of robotics. It can write the manuals, it can build the working prototypes, and then it can simply drop the technology and walk away into the dark. An entire branch of advanced engineering can vanish without a trace, leaving nothing but an old, ignored book. We still have the text of the Pneumatica. We can read Heron's exact mechanical instructions today. But what happens when the blueprints survive, but the operational knowledge to maintain them does not? Number 7. The Hufeng Didong Yi. When the ground shakes, human perception is strictly local. We only feel an earthquake if we are standing directly in the path of the violent seismic wave. If a tremor happens 300 miles away, the human body feels absolutely nothing. We are completely blind to the subtle, deep earth vibrations moving beneath our feet. But in the year 132 CE, a Chinese polymath and astronomer named Zhang Heng built a machine that bypassed this biological limit. He constructed a massive, ornate bronze vessel that acted as an artificial nervous system for the Earth itself. It was designed to detect earthquakes hundreds of miles away, long before a human being could sense a single vibration. We know the precise details of this machine because it was meticulously documented in the Book of Later Han. This is a highly credible official history compiled by the scholar Fan Ye. The record describes an instrument called the Hufeng Didong Yi. It was a heavy, domed bronze jar measuring roughly 6 feet across. On the outside, 8 bronze dragons faced outward, aligned with the 8 primary compass directions. Each dragon held a small bronze ball in its mouth. Directly below each dragon sat a bronze toad, its mouth wide open, waiting to catch the sphere. When an earthquake occurred far in the distance, the internal mechanism would detect the invisible wave. A single dragon would drop its ball into the mouth of the toad below. The impact produced a loud, ringing metallic clang that echoed through the imperial court. The fallen ball gave the emperor the exact directional coordinate of a disaster that no one in the room had actually felt. The original physical device is gone. It was lost during the violent political transitions of later centuries. But the historical accounts of its absolute accuracy remain undisputed in the official records. The text documents a specific incident where the machine triggered, dropping a ball to indicate a seismic event in the northwest. The imperial court was highly skeptical. They had felt absolutely nothing. The ground in the capital was perfectly still. But several days later, exhausted messengers arrived on horseback. They brought reports of a massive earthquake in the exact northwestern province the bronze jar had identified. The event was real, and the mechanical early detection was flawless. The true mystery lies hidden inside the bronze shell. Historical descriptions explain that the device relied on an incredibly delicate internal pendulum mechanism. This heavy pillar was suspended directly in the center of the jar. As a distant, imperceptible seismic wave passed through the earth, it would disturb this heavy pendulum just enough to trigger a complex 8-armed system of internal levers. That microscopic shift was enough to release the correct ball. But there is a massive physical problem with this simple explanation. A purely mechanical pendulum, operating without digital sensors or modern electronic amplification, should not be capable of that level of sensitivity. Under our current understanding of ancient metallurgy, the inherent friction of the heavy bronze levers should have absorbed the microscopic vibration before it ever reached the mouth of the dragon. History documents a level of mechanical sensitivity that completely breaks our modern framework of ancient engineering. Zhang Heng did not just build a clever physical toy, he engineered a passive mechanical sensor that successfully bridged the gap between a microscopic deep earth vibration and a massive physical reaction. He achieved this using nothing but heavy bronze, gravity, and a profound lost understanding of kinetic energy. We have the official historical description. We know exactly what the device looked like, and we know the fundamental mechanics of its internal pendulum design. If the tech survives and the basic physics are documented, why can't modern engineers simply rebuild it? In 2005, the Chinese Academy of Sciences decided to answer that exact question. They launched an official, highly funded reconstruction project to rebuild Zhang Heng's ancient seismoscope. The stakes were high. They wanted to prove that the historical records from the 2nd century were physically accurate. They had the surviving texts. They had top-tier modern mechanical engineers. They knew the physical dimensions, the heavy bronze materials, and the internal pendulum structure. On paper, it was a completely straightforward reverse engineering assignment. They just had to follow the instructions. But there is a massive difference between building a museum replica that looks identical to the original and building a machine that actually functions using only ancient materials. Casting a heavy bronze vessel is easy. Decorating the outside with 8 bronze dragons holding small metal balls is just basic metallurgy. But the machine is not art. It is a highly calibrated tool. The internal mechanism relied on a heavy central pendulum. When a distant earthquake occurred, the subtle seismic wave was supposed to move the heavy pendulum just enough to trigger a series of internal levers. This would open the mouth of one specific dragon on the outside of the vessel, dropping a bronze ball into the mouth of a waiting bronze toad below. This action gave the emperor the exact direction of the distant earthquake, making a massive pendulum sensitive enough to register a tremor 300 miles away, while simultaneously ignoring local vibrations like a passing wooden cart, is an incredibly difficult physics problem. When the modern engineers built the device using strictly ancient methods, it failed. The modern reconstruction could not match the historical sensitivity. The heavy bronze pendulum inside simply would not trigger the drop mechanism unless the seismic wave was incredibly close and violent. The internal physics described in the surviving texts refused to behave in the real world. The friction on the internal levers was too high. The balance of the massive weight was too clumsy. The failure was so complete that the modern team had to make a quiet, uncomfortable compromise. To make the replica work for public demonstrations, they had to hide modern electronic sensors inside the bronze shell. They had to cheat. They used 20th century digital technology to simulate a purely mechanical reaction. It was a reaction that a 2nd century engineer achieved with nothing but shaped metal, gravity, and raw physical intuition. It was not a lack of effort by the modern team. It was a profound lack of ancient tacit knowledge. The ancient metallurgists who built the original machine possessed undocumented techniques that we simply do not have. They understood something profound about friction reduction. They knew exactly how to balance a heavy mass on a hair trigger pivot so perfectly that the movement of the Earth's crust could trigger it, but a heavy footstep could not. This delicate balancing act was never written down in the official history. It was a physical feeling for the metal. It was a highly specialized skill passed down from master to apprentice, and eventually, that chain of mastery was broken. When the last engineer who knew how to balance that pendulum died, the technology died with him. This exposes the fundamental illusion of the surviving blueprint. Having the schematic is completely useless without the lost physical intuition of the original builders. We can see the parts. We know what they are supposed to do, but we do not know how they made them work. The hardware is just a heavy bronze shell without the operational software of the human mind that built it. This leaves us with a terrifying realization about the fragility of human engineering. A highly sensitive desktop instrument is just one isolated puzzle. It proves that we have lost the ability to coordinate small-scale, high-precision mechanics. But if this small-scale mechanical precision is entirely lost, what happens when we look away from desktop models? What happens when the scale of the mystery expands and we look at massive mechanical systems? Number 6. Caligula's Nemiships. In 1929, an engineering project in Italy drained a volcanic lake just outside of Rome. They did this to investigate local rumors of ancient wrecks. At the bottom of the thick mud, they did not find a few rotting planks or a simple fishing boat. They recovered the nearly intact physical hulls of two massive floating palaces. We are typically taught a very safe, restricted version of ancient naval history. We are told to picture simple wooden galleys, powered by banks of sweating oarsmen. We imagine small, fragile merchant vessels relying on unpredictable winds to creep along the coastline. The Nemiships completely shatter that assumption. These vessels were the size of modern car ferries. They measured over 230 feet in length. They were not just boats designed to cross water. They were floating architecture, engineered to hold immense, static weight. When researchers from the Museo delle Navi Romane finally examined the recovered wrecks, they found a level of infrastructure that defied the ordinary timeline of technology. The decks of these ships were paved with elaborate, heavy marble mosaics. They supported stone pavilions and bronze statues. But the real shock was the mechanical infrastructure hidden beneath the surface. The hulls contained an advanced pressurized network of lead plumbing. They featured running hot and cold water distributed throughout the vessel. They even possessed integrated thermal heating systems, routing hot air horizontally beneath the floors to warm the luxury baths. For centuries, local fishermen had pulled up strange bronze artifacts in their nets. They told stories about giant, impossible ships sleeping at the bottom of the lake. Historians routinely dismiss these stories as exaggerated myths. They assumed the Roman Empire simply did not possess the structural engineering capacity to build something of this staggering scale. But the physical drainage of the lake forced the academic world to face the truth. The massive hulls were dragged onto the shore. The copper pipes, the sophisticated bronze valves, and the immense timber frames were physically measured and catalogued. The massive scale was not an exaggeration. The ships actually existed. But building a massive, heavy structure on the water is only half the engineering problem. A ship of that unbelievable size, carrying thousands of tons of stone, water, and metal, cannot simply drift. It requires complex structural coordination to keep from breaking apart under its own weight. More importantly, it requires large-scale drive and steering systems. The surviving Roman texts tell us absolutely nothing about how these floating palaces were actually moved or maneuvered. A ferry-sized vessel carrying heated baths requires immense mechanical force to rotate in the water without snapping its rudders. Those steering and drive mechanisms remain completely unidentified. The Nemiships force us to accept a frightening reality about the historical record. Civilizations achieved megascale engineering. They perfected it, they funded it, and they deployed it. And then, it was completely erased from human memory. If the deep mud of the lake had not perfectly preserved the physical timber, modern science would still believe these ships were just a poetic legend. The written manuals, the naval blueprints, and the operational knowledge for this level of architecture simply vanished. We are left looking at the massive wooden ribs of a lost technology. We know they built floating cities. We know they put them on the water. But how did ancient engineers actually control the immense rotational forces required to steer them? The answer to that mechanical problem was buried in the exact same mud that preserved the hulls. When researchers sifted through the wreckage of the two ships, they found something that should not have been invented for another 1,500 years. They found the physical components of a working ball-bearing system. To understand why this is a timeline-breaking discovery, you have to look at the brutal physics of moving massive weight. Friction is the absolute enemy of mechanical movement. The Nemiships were not just heavy wooden shells. They carried marble floors, bronze statues, and functioning plumbing systems. If you try to rotate a heavy steering column or a massive statue platform sitting flat on another wooden surface, the sliding friction will immediately lock it in place. The kinetic energy required to twist it will simply snap your wooden levers or shear the timber in half. To solve this, you have to fundamentally change the physics of the joint. You have to convert sliding friction into rolling friction. You have to separate the two heavy surfaces with perfectly uniform spheres, allowing the immense weight to glide smoothly on tiny, rolling points of contact. We are taught that this profound mechanical leap was a Renaissance invention. The official timeline says Leonardo da Vinci sketched the first theoretical ball bearings in the early 16th century. We are told that industrial engineers finally managed to build them centuries later, launching the modern mechanical age. But the physical evidence says the official timeline is completely wrong. Today, inside the Museo Nazionale Romano, you can look at the surviving rotational mechanisms recovered directly from the Nemi ruins. They are not theoretical sketches. They are heavy, functional, physical hardware. Ancient engineers carved perfectly uniform wooden spheres. They capped them with precise bronze trunnions. They locked these small globes into fixed circular wooden tracks with bronze straps. These spheres were spaced symmetrically to distribute massive vertical weight, allowing the heavy platforms above them to rotate freely and smoothly. They did not just invent the concept of the ball bearing. They engineered it at an industrial scale to handle the immense structural loads of a floating palace. These artifacts force a massive correction to our understanding of human progress. They are physical proof that the fundamental mechanics of the modern drive system were already solved by the 1st century. The Romans did not rely on primitive brute force to move heavy machinery. They used elegant, high-precision kinetic engineering. They understood how to manipulate physics to make thousands of tons of wood and marble rotate on demand. And then, the Roman world fractured. The ships burned and sank to the bottom of the volcanic lake. The engineers died. The Romans possessed advanced mechanical steering platforms, and that knowledge was completely, systematically lost to time. For nearly 2 millennia, the world forgot that heavy rotational friction could be managed this way. The machine broke, and the cognitive software required to rebuild it was gone. A critical mechanical drive system existed centuries before we thought possible. It was a masterpiece of mechanical coordination. And then it vanished entirely, lying in the dark water until a modern engineering project finally drained the lake. We did not invent the ball bearing. We just eventually remembered it. But if they mastered complex mechanical rotation in the 1st century, they needed materials that could withstand that constant kinetic stress without shattering. What other advanced metallurgy did they control? Number 5. Wood, steel, and ancient nanotubes. When we ask what kind of advanced metallurgy the ancient world controlled, the answer usually leads to weapons. Specifically, it leads to the legendary Damascus sabers, forged from Indian Wootz steel during the 17th century. These blades were famous across the world for their incredible sharpness and their distinctive, watery surface patterns. For hundreds of years, historians assumed this was simply the result of talented blacksmiths folding high-carbon iron over and over again. But the real secret to their strength was not just a hammering technique, it was a microscopic physical structure. Today, the word nanotechnology feels strictly modern. We hear it and immediately picture sterile laboratories, abstract physics, and scientists in clean suits. We think of it as a recent theoretical breakthrough. But carbon nanotubes are not just mathematical concepts. They are actual, physical objects. They are microscopic cylinders made of carbon atoms, and they are some of the strongest structures ever discovered by human science. For centuries, nobody had any idea that these microscopic cylinders were hiding inside ancient weapons. The blades were simply known to be unusually strong and flexible. Then, in the year 2006, a team of researchers led by Peter Reibold published a groundbreaking paper in the journal Nature. They decided to look closer at the metal than anyone ever had before. They dissolved a small piece of a 17th century Damascus saber in hydrochloric acid and placed the remains under a high-resolution electron microscope. The images they captured completely broke the traditional timeline of metallurgy. They did not just find a high-quality mix of iron and carbon. They found perfectly formed carbon nanotubes, and inside those microscopic tubes, they found nanowires of cementite, a hard, brittle iron compound. The nanotubes encased the brittle wire, giving the steel its impossible combination of flexibility and shattering strength. This kind of microscopic architecture does not happen by accident. You cannot randomly hit a piece of hot iron until carbon atoms form perfect cylinders. The concentration and alignment of these tubes required a highly specific, tightly controlled chemical environment. The carbon had to be introduced at exact temperatures, utilizing specific organic materials like wood and leaves inside a sealed clay crucible. Yet the ancient Indian metallurgists who perfected Wootz steel did not have electron microscopes. They did not have digital thermometers or chemical analysis software. They achieved this structural perfection using lost crucible techniques. They relied entirely on visual cues, the exact color of the flame, and a deep physical intuition that modern science cannot easily measure. They were manipulating matter at a molecular level long before the molecule was even defined. The ancient smiths engineered high-carbon steel from the inside out, forcing carbon atoms to bond into structural cylinders. They achieved a state of microscopic material perfection using nothing but earth, fire, and an unwritten mastery of chemical coordination. They built nanotechnology with their bare hands. This changes how we must view the progression of human knowledge. Nanotechnology is not a strictly modern invention. It was an ancient artisanal reality. We know it existed because the physical evidence is sitting right there under the electron microscope lens. But the actual human process required to forge it was completely lost to time. Modern science can see the carbon nanotubes inside the old steel, but without the tacit knowledge of the ancient smiths, modern engineers cannot perfectly rebuild the original crucible process that made them. A highly advanced chemical formula was perfected, utilized for generations, and then entirely erased from human memory. It proves that technological progress can run backward. But if a process this complex survived for centuries before it finally vanished, it means someone was carefully maintaining it. How did ancient smiths protect these incredibly advanced chemical formulas from degrading over time? Number 4. The untarnished sword of Goujian. The discovery of carbon nanotubes inside ancient steel proved that early metallurgists could manipulate the internal molecular structure of a weapon. But engineering internal strength is only half the battle. The other half is ensuring that the metal actually survives the elements. Today, we spend billions of dollars trying to protect our modern industrial steel and iron from moisture. We use synthetic chemical coatings, complex galvanized layers, and constant physical maintenance. We do this because we know that if you leave a modern tool in the dirt, moisture and oxygen will immediately attack it. Within a single human lifetime, buried metal pits, rusts, and turns back into raw ore. For ancient bronze, the standard result is a fragile green oxidized crust. We accept this rapid chemical decay as a fundamental law of nature. Left alone in a damp environment, the Earth always reclaims human engineering. But in 1965, an excavation team working in central China completely broke that physical expectation. They were surveying an ancient, waterlogged burial site. The underground tomb had been soaking in dark, wet groundwater for over 2,000 years. The environment was perfectly designed to destroy metal. The wooden structure were rotting away, but inside one of the flooded coffins, researchers found a black wooden scabbard lying next to a skeleton. When they pulled the weapon free from the scabbard, it did not crumble into green dust. The Hubei Provincial Museum took custody of what is now known as the Sword of Goujian. It is a 2,500-year-old bronze blade. It was not just physically intact, it was perfectly sharp. The metal was completely unoxidized. The surface was gleaming, covered in a flawless, dark geometric pattern. It looked exactly as it did the day it was forged, 2.5 millennia ago. When an archaeologist carefully tested the edge of the blade, it easily drew blood. It is very easy to look at an impossible artifact like this and slip into the language of magic or myth. But this is not a legend. It is a physical object sitting under glass in a modern museum. Its survival is not a supernatural event. It is a matter of strict, highly calculated chemistry. Metals do not simply decide to ignore oxygen and water. They have to be physically forced to ignore them. The flooded environment of that ancient tomb was actively hostile to the blade. A normal bronze sword dropped into that exact same mud would have been eaten away in a matter of centuries. Because the damp environment should have destroyed the weapon, its survival proves that the preservation was deliberately engineered. The original builders anticipated the chemical decay of the earth and actively blocked it. Ancient Chinese weaponsmiths did not just forge a sharp piece of bronze, they engineered a permanent, localized anti-corrosion treatment. This was a massive technological advantage on an ancient battlefield. But an advantage like that is only useful if your enemies do not know how to replicate it. The chemical formula was a tightly controlled military asset, protected by extreme state secrecy. That state secrecy was incredibly effective. It kept the formula out of enemy hands for generations. But secrecy is a very dangerous way to protect technology. Because the formula was never widely shared or published, it became incredibly fragile. When the state eventually collapsed and the specific lineage of weaponsmiths died out, the institutional knowledge died with them. State secrecy successfully preserved a chemical formula so well that the physical result survived millennia underground, even while the knowledge of how to achieve it was permanently erased from human history. We have the physical sword. We know the preservation worked perfectly, but what exactly was coated on the blade's edge to defy chemical decay? To answer that question, researchers at Fudan University subjected the blade to an advanced technique known as proton-induced X-ray emission analysis. In the scientific literature, this is referred to as PIXE mapping. This is not a simple visual inspection or a basic acid test. PIXE mapping allows researchers to read the precise atomic fingerprint of a metal. By firing a controlled beam of protons directly at the artifact, scientists can measure the specific X-rays that bounce back. This reveals the exact chemical makeup of the material, element by element, without causing a single scratch to the pristine surface. When the researchers looked at the atomic map of this 2,500-year-old weapon, the results were entirely unexpected. They did not find a simple, uniform bronze casting. Instead, they discovered a highly specific, exceptionally complex sulfur-copper alloy, concentrated exclusively along the very edges of the blade. The thick central core of the sword remained standard, flexible bronze, but the microscopic outer rim, the part that actually cuts, was chemically altered. This sulfur-copper compound acted as a permanent, impenetrable shield against moisture, oxygen, and time. This was not a lucky strike of the hammer. It was not the result of an accidental mixing of metals, and it was certainly not a raw, unrefined ore pulled blindly from the earth. The clean separation between the flexible bronze core and the dense, sulfur-coated edge proves an undeniable fact. This was a deliberate, tightly controlled, multi-step chemical formula. The ancient weaponsmiths understood exactly what they were doing. They isolated the elements, calculated the exact ratios, applied the coating, and successfully outsmarted natural chemical decay. But knowing what elements sit on the surface of the blade is not the same as knowing how to put them there. The exact chemical ratios, the required temperature of the forge, and the physical application methods were completely lost. In the ancient world, a blade that never dulled, never rusted, and never broke was a profound military advantage. Naturally, this kind of power was protected by absolute, deliberate state secrecy. The metallurgists who perfected this technique did not publish their findings in a public archive. They kept the sulfur-copper formula locked within a small, highly trusted circle of imperial craftsmen. That extreme level of secrecy was incredibly effective in the short term. It kept the formula out of enemy hands for generations. But state secrecy is a very dangerous way to protect human technology. Because the formula was never widely shared, distributed, or published, it became an incredibly fragile piece of institutional software. When the ruling state eventually collapsed, and the specific lineage of weaponsmiths died out, the institutional knowledge died with them. State secrecy successfully preserved a chemical formula so well that the physical result survived millennia underground in a damp tomb. The formula itself worked perfectly, defying the natural laws of corrosion. But the institutional knowledge, the tacit understanding of how to actually execute the chemistry, was permanently erased from history. We are left holding the final product, completely unable to replicate the process. If highly advanced chemical formulas could be entirely lost to state secrecy, the timeline of human progress becomes much darker. It means knowledge does not always move forward. It means technology can be deliberately hidden, hoarded, and eventually forgotten. But chemistry is invisible to the naked eye. If these invisible formulas were lost to secrecy, What happened to the massive physical infrastructure of the ancient world? Number 3. The 1500-year desert engine. When we build massive physical infrastructure today, we accept a very specific vulnerability. Modern water pumps, concrete dams, and municipal pipelines are incredibly powerful, but they are also incredibly fragile. They require constant, daily maintenance. If you remove the engineers, the lubricants, and the replacement parts, a modern hydraulic grid will tear itself apart in a matter of months. We build for the present, assuming our descendants will be there to fix our decaying pipes. We assume that constant rebuilding is just the necessary cost of survival. But in the arid plains of southern Peru, an ancient civilization took the exact opposite approach. They looked at a dead, hyper-arid environment and decided to build a machine that would never need to be turned off. They engineered a network of spiraling stone funnels known as the puquios. These are not simple, static wells where water just pools in the dark. They are deep, descending corkscrews strictly lined with river cobbles, plunging directly into the earth. For the last 15 centuries, these stone spirals have been successfully pushing fresh, cold water through one of the most uninhabitable deserts on the planet. The Cantalloc aqueducts are a prime example of this system. According to the official surveys by the Peruvian Ministry of Culture, these spirals are not just interesting archaeological anomalies. They are not dead ruins waiting behind a velvet rope. They are active, functioning infrastructure. Local populations still rely on the exact same hydraulic network that was laid down over 1500 years ago. The water still flows. The surrounding desert still blooms. Modern humans are drinking from an ancient machine that simply refuses to break. This is where the modern engineering mind begins to stumble. If you want to move massive volumes of water across long horizontal distances underground today, you are fighting a brutal war against friction. The earth wants to slow the water down. The tunnel walls drag at the current until it inevitably stagnates. To overcome that resistance, modern engineers use heavy industrial pumps. We use spinning metal turbines, high-voltage electrical grids, and a massive, continuous supply of kinetic energy. We beat the friction with brute force. The Nazca engineers accomplished the exact same result with absolutely zero moving parts. There are no bronze gears to rust beneath the sand. There are no wooden wheels to rot in the damp dark. There is no mechanical friction to wear down over time. By removing the moving pieces, they removed the risk of mechanical failure. They achieved a level of infrastructural permanence that modern city planners cannot even begin to promise. The Nazca did not just build a temporary fix to get through a long drought. They engineered permanent survival in an uninhabitable zone. They created a geological engine that outlasted the very civilization that conceived it. The hardware is so perfectly integrated into the dry landscape that it operates like a natural law, completely indifferent to the centuries passing above it. We can stand at the edge of these stone funnels and watch the water moving. We can measure the steady, relentless output of the deep channels. We know the system works. But water flowing horizontally underground over massive distances requires serious physical pressure. Gravity alone is not enough to maintain this kind of constant velocity through narrow, subterranean rock. If there are no mechanical pumps, no heavy gravity drops, and no spinning turbines, what is actually pushing the water? How did they power this massive underground flow without a single moving machine? To answer that question, we have to look down from space. In 2016, a team led by researcher Rosa Lasaponara analyzed the site using high-resolution satellite imaging. The project was called the ITACA Satellite Survey. From the ground, the ancient rock funnels just looked like descending stone staircases. For decades, archaeologists assumed they were simple access points, built so people could walk down and clear debris from the water channels. But from orbit, a completely different pattern emerges. The satellite mapping proved that the orientation and placement of these spirals are not random. They are highly specific, and they are perfectly aligned with the prevailing desert winds. This changes what the spirals actually are. They are not just retaining walls to hold back the dirt. They are precise aerodynamic wind catchers. The ancient engineers shaped the stone to capture the dry wind sweeping across the desert surface. The spiral design acts like a natural funnel for barometric pressure. It snatches the moving air and forces it downward. As the wind is pushed deeper into the tightening spiral, the air pressure increases. When it finally hits the subterranean water trench, that concentrated burst of air acts like a piston. It physically pushes the water forward. The satellite imaging proved that this was not a localized trick. It was a massive, coordinated hydraulic network spanning the desert. Every individual spiral was placed to catch the wind at the exact right angle, driving a continuous subterranean current. The surface winds provided the kinetic energy that the underground water lacked. By spacing these stone funnels at calculated intervals, the builders created a perpetual pressure system. The wind never stops blowing across the arid plains, so the water never stops flowing through the rock. This requires a profound shift in how we view ancient infrastructure. This was not a passive system relying on gravity. Gravity simply pulls water downward. This was active atmospheric manipulation. They built a massive pneumatic pump out of nothing but dry rock and empty air. They understood how to compress gas on the surface to move liquid underground. This is an application of advanced fluid dynamics. It requires an intimate, calculated understanding of environmental pressure, structural resistance, and aerodynamic flow. But the strangest part of this discovery is not the physics itself. It is the complete absence of instructions. To build a network this precise today, you would need complex mathematical models. You would need to calculate wind speed, tunnel friction, and subterranean fluid resistance. Modern engineers would require thousands of pages of technical blueprints and operational manuals to coordinate construction on this scale. The ancient engineers mastered this entire invisible machine without leaving a single written manual. There is no surviving blueprint. Not a single text exists to explain how they calculated the aerodynamic angles or the exact spacing of the funnels. The hardware is still sitting in the desert, functioning perfectly, but the software of their minds is completely erased. They did not just stack some lucky rocks. The survival of the entire Nazca civilization relied on this unwritten, invisible atmospheric machine. They engineered permanent survival in one of the harshest environments on the planet, using a technology that left absolutely no paper trail. They did it so well that their machine outlived the people who built it by 15 centuries. They harnessed the invisible forces of the sky to move the invisible water below the earth. But if they could manipulate wind and water with such perfect, undocumented precision, what could they do with solid matter? Number 2. The nanotech chalice. The manipulation of solid matter usually makes us think of massive stones, heavy bronze swords, and towering concrete seawalls. But the ultimate mastery of the physical world does not always happen at the macro level. Sometimes the most profound engineering happens in a realm that ancient eyes could not even see. Today, the word nanotechnology feels exclusively modern. We associate it with silicon microchips, sterile clean rooms, and highly advanced electron microscopes. By definition, nanotechnology is the science of manipulating matter at an atomic and molecular scale. It is the ability to engineer materials at a depth far smaller than the wavelength of visible light. We assume this is a threshold of science that absolutely requires electricity, modern optics, and a deep theoretical understanding of quantum physics. Our standard timeline tells us that ancient builders were simply banging rocks together and pouring hot metal, completely blind to the microscopic world. But resting in the collection of the British Museum is a physical artifact that breaks that assumption entirely. It is a 4th century Roman glass vessel known as the Lycurgus cup. Under normal, ambient lighting, the glass appears to be a dull, opaque green. But when a light source is placed directly inside it, shining through the material from behind, the glass immediately transforms into a glowing, translucent red. For decades, historians documented this as a curious artistic anomaly. The standard academic belief was that Roman glassmakers simply stumbled onto a lucky mixture of raw materials, creating a strange optical trick by sheer accident. But in the late 20th century, modern scientists finally placed fragments of similar Roman dichroic glass under a scanning electron microscope. The glass did not change color by accident. The Roman glassmakers had impregnated the material with a highly specific ratio of gold and silver. They ground these precious metals down to exactly 50 nanometers in diameter. That is 1,000 times smaller than a single grain of salt. It is a scale so unimaginably tiny that it completely bypasses human sight. This was not a lucky accident involving contaminated dirt. You do not accidentally grind gold and silver into 50 nanometer spheres and suspend them in a perfectly uniform structural matrix. The color change from green to red is the direct result of electrons vibrating on the surface of these specific metallic nanoparticles when light hits them. It is a highly intentional, integrated chemical engineering process. The creators knew exactly what they were doing. They were deliberately altering the optical properties of the glass by strictly controlling the size, shape, and concentration of invisible particles. Roman glassmakers engineered matter at an atomic scale centuries before the first crude optical microscope was ever invented. They could not see the nanoparticles they were creating. They had no theoretical models of electron vibration, yet they possessed the tacit physical intuition required to repeatedly execute a flawless nanotechnological process. They manipulated the foundational building blocks of solid matter entirely by feel, by inherited memory, and by a profound chemical brilliance. This artifact completely shatters the safe, linear narrative of human progress. It proves that an integrated mechanical and chemical genius existed in the ancient world, operating at a level we believed was strictly the domain of modern science. They did not just build heavy walls or forge sharp blades. They achieved complete mastery over the physical world, manipulating the deepest microscopic structures of reality itself. And just like the desert wind engines, the operational blueprints for this nanotech simply vanished. But if they possessed the engineering capacity to manipulate the invisible world with absolute precision, we must ask a final question. If they could engineer the microscopic, what happened when they scaled up to the massive? Number 1, the 100-ton puzzle. We have seen how ancient engineers manipulated matter at the microscopic scale. We have seen them engineer 50 nanometer particles of gold and silver into Roman glass. But the final mystery requires us to scale up to the absolute limit of physical engineering. We must move from the invisible world to the largest physical machines of antiquity. Today, lifting a 100-ton solid physical load is a massive logistical event. It requires industrial hydraulic cranes, heavy steel counterweights, and multiple teams of engineers. The sheer weight of that much raw matter violently crushes anything caught beneath it. Modern teams calculate these lifts down to the millimeter. If the object shifts slightly during the descent, it destroys the foundation. If you drop it, the operation is over. Ancient civilizations achieved the exact same physical result, but they did it using a mechanical vocabulary we still cannot translate. Look at the Sacsayhuaman Fortress, high in the Andes Mountains of Peru. Recognized as a UNESCO World Heritage Site, this massive complex was constructed by the Inca. The site is defined by its immense interlocking dry stone walls. These are not standard rectangular bricks. They are massive polygonal blocks of solid andesite rock. Many of these individual stones weigh over 100 tons. They are not just stacked on top of each other. They are fitted together like a massive three-dimensional puzzle. The angles are irregular, complex, and totally unique to each block. There is no chemical mortar holding them in place. Yet, the geometric joints between these 100-ton boulders are so tight that a single piece of paper cannot pass between them. This physical reality completely breaks the standard historical explanation. We are usually told that ancient megastructures were built through simple brute force. The standard theory relies on wooden rollers, thick ropes, and an unlimited supply of human manual labor. But brute force is inherently sloppy. Dragging 100-ton rocks over rough mountain terrain does not produce a perfect millimeter-tight seal. Unlimited labor can certainly push a heavy object, but it cannot explain the microscopic alignment of massive, irregular polygons. Think about the physics of the final placement. You do not just drop a 100-ton block of andesite into a perfectly matched geometric socket. If it falls even an inch too fast, the extreme weight will fracture the edges of the stone below it. It has to be lowered with absolute, controlled precision. It requires a slow, stabilized descent that simple wooden levers and raw muscle cannot easily provide. A civilization effectively moved mountains, and they did it with a precision we cannot replicate using their known historical tools. The exact transport mechanism, the lifting technology, and the structural coordination system are completely missing from the historical record. This is not just a heavy wall. It represents the ultimate lost civilizational scale technology. Ancient engineers possessed an operational method for handling immense weight that modern science cannot reverse engineer. We know they lifted the stones. We have the physical walls to prove it. The machine of their society worked perfectly. But if these massive physical achievements survived the centuries, where did the blueprints go? How did the institutional knowledge required to build on this scale simply vanish? To understand exactly how completely that knowledge vanished, we have to look closely at the walls themselves. We have to look at the microscopic details of the massive andesite joints at the Sacsayhuaman Fortress. When you stand beneath these walls, the sheer size of the stones overwhelms your vision. But the real mystery is not just the weight. The real mystery is what happens where the stones actually meet. Modern architectural surveys, published in the Journal of Archaeological Science, have spent years examining the precise contact points of these massive blocks. When modern engineers construct a heavy load-bearing wall, they rely on a very specific set of tools. They use industrial diamond-tipped saws to cut standard, perfect angles. And because even the best modern blades leave microscopic gaps, they use chemical mortar to seal the joints and distribute the weight. But the ancient builders of the Sacsayhuaman fortress used a system that relied entirely on perfect, dry friction. The 100-ton blocks are polygonal. This means they do not have standard square edges. They have multiple, irregular sides, interlocking in highly complex geometric patterns. Yet they fit together so tightly that a single piece of paper cannot pass between the stones. To figure out how this was physically accomplished, researchers were looking for the standard mechanical signatures of ancient masonry. When you shape heavy stone, you leave a forensic record of your violence. The scientists expected to find the microscopic grooves of heavy bronze chisels. They expected to see the blunt, crushing patterns of harder stone hammers. They assumed they would find the deep, dragging scars left by thick ropes and wooden sleds. Instead, the surveys confirmed something entirely unexpected. Across the massive, perfectly locked faces of these stones, there is a complete lack of tool marks on the interlocking joints. This lack of physical evidence completely breaks our standard understanding of ancient construction methods. The simple, accepted narrative is that early civilizations achieved these structures through brute force. We assume they just threw unlimited manual labor at the problem, slowly grinding the rocks together over decades until they finally settled into place. But grinding leaves massive friction scars. Chiseling leaves directional grooves. The absolute smoothness of these joints proves that brute force was not the primary mechanism. They used an entirely unknown coordination system to shape and place these stones. They mastered a structural coordination process that leaves absolutely no manufacturing trace for modern engineers to reverse engineer. You cannot simply lift a 100-ton polygonal block and test its fit against another irregular stone. You cannot just take it back down to shave off a few extra millimeters. The kinetic stress of doing that repeatedly would crush the delicate outer edges and shatter the stone. You have to know the exact three-dimensional shape of the target gap before the new block ever leaves the quarry. And you have to shape it with a technique that leaves the final connecting surface completely unscarred. The sheer physical scale of this achievement makes the absence of surviving blueprints absolutely deafening. We are looking at a level of civilizational engineering that operated with the precision of a watchmaker, but on the scale of a mountain. To coordinate this kind of construction, there had to be an operational manual. There had to be a standardized method of measuring, cutting, and lifting that could be taught to thousands of workers across generations. Yet the exact transport and lifting mechanism remains completely unidentified. It implies a lost method of manipulating solid matter that we cannot recreate, even in theory. They left behind a flawless physical machine made of interlocking stone, built to withstand the heaviest earthquakes without a single drop of mortar. The hardware is sitting right in front of us, defying every modern attempt to explain its creation. But if these massive physical structures survived the centuries, where did the blueprints go? To answer the question of where those massive blueprints went, we have to look at how an ancient superpower actually stored its memory. The Imperial Roman archives, along with the great libraries of the ancient world, were designed to be the ultimate repositories of human achievement. They held the detailed technical manuals, the logistical ledgers, and the precise architectural diagrams for empires that spanned continents. But today, those central data hubs are completely empty. To understand the true scale of what was lost, imagine walking into a massive modern data center and magnetically wiping every single hard drive. You would still have the glass walls, the titanium server racks, and the heavy physical cooling fans. The hardware would remain perfectly intact, but the software, the invisible code that actually told the machines how to function, would be completely erased. The physical shell survives, but the operating system is dead. That is exactly what happened to the ancient world. There is a unified historical consensus regarding the collapse of antiquity. It was not just a slow, romantic decline of art and philosophy. It was the total, systematic erasure of centralized technical blueprints. When the imperial institutions collapsed, the paper trail of early engineering burned with them. The artifacts themselves survived because they were made of bronze, marine concrete, and solid andesite stone. But the fragile papyrus scrolls that explained how to cut those stones, how to cast that bronze, and how to mix that concrete were completely turned to ash. The institutions that trained the engineers simply stopped existing. We naturally want to believe that human technological progress is a straight, unbroken line of accumulated knowledge. We are taught in school that each generation simply inherits the tools of the past and steadily improves upon them. The narrative is always moving forward. But the physical evidence we have looked at tells a much darker story. It proves that knowledge is incredibly fragile. It proves that a civilization can reach the absolute peak of mechanical, chemical, and structural engineering, and then simply forget how they did it. Centuries of highly advanced operational blueprints were deliberately hoarded in central hubs, locked behind state secrecy, and then permanently erased. This left the survivors with an inheritance of silent physical machines. Every artifact we have examined points to the exact same conclusion. We are entirely surrounded by hardware, with no surviving software. From the differential gears calculating celestial orbits, to the silent wind pumps hidden in the Peruvian desert, to the 100-ton stones locked together without mortar, we are living in the ruins of a forgotten mechanical age. The destruction of these central archives did not just slow down human progress, it erased the operational manuals of the ancient world completely. It created an unrecoverable missing chapter in our own historical timeline. We can measure the massive interlocking stones, we can run advanced X-ray scans on rusted bronze gears, and we can look at ancient steel under an electron microscope. Modern science can confirm that these machines worked perfectly, but the human minds that actually understood the underlying physical intuition are gone forever. We are trying to read a book where half the pages have been torn out. We have spent this time looking at the concrete evidence that history accidentally left behind. We have seen the physical proof of technologies that modern science still cannot easily reverse engineer. But if an entire mechanical age could be this thoroughly buried, erased, and forgotten, it leaves us with one final, unavoidable thought. What other impossible machines are still waiting in the dark?